Thank you very much. Does it sound good? I'm not used to speaking with this. Okay, so my name is Marketa Adamova. I am from Prague, and when I don't work as a developer for NomNom, I help running Prague Lambda meetup, and I'm involved in loads of Clojure teaching. So today I'll be speaking about our road trip to component, and basically it's how we decided to migrate from Ruby codebase to Clojure, what issues we had, and why Stuart's component library actually solved a lot of it for us. And I'm hoping it might help to loads of you which like Clojure to see that it's actually not so hard and that you might push it in your company as well. So let's get started now. Let's see if it's working. Perfect. So let me give you a quick intro what we do. We're called NomNom Inside, and no, we don't do food, as everybody's thinking. We do customer feedback processing, and NomNom is the place where you want to gather all your customer feedback. And what does it mean? If you're a big company and you might have your ticketing system, you might have an intercom, you're active on social media, that's all the places where your customers are speaking to you and speaking about you. And we help to gather all the feedback into a single place, and we help you to make it easy for you to organize it, search it, and share it with your team. The company was founded 2 years ago, and we are 3 months in production. We're a very small team, there's 7 of us. And we're fully remote. We're distributed across 2 continents and 5 countries at the moment. So, since most of you are technically, you don't really care what we're doing, so what are kind of the problems we need to solve? So the first problem we have is that we need to import a lot of data, and the data is of various formats because we're connecting to all those third-party APIs. And also, of course, our customers don't want all data. They want it as much up-to-date as they can have it. Once we get the data, it sounds very simple: process, analyze, and store. That's one of the big challenges, is that if you importing data from ticketing systems and stuff like that, it's a lot of rubbish data. So you don't want to be presenting millions of auto replies as a customer feedback. So great, we have all the data. We are going to present the data to user. I, as a backend person, always says like, that's easy. Nobody cares about that. And only working in a small team, I realize how hard UX is. So one of the last challenges, and it will be kind of important through the migration, was that we need to be able to do, our customers love to search through their data. And we have some fairly large customers, which even after cleaning will have hundreds of thousands of documents, and we need to be able to let them search from it in terms of milliseconds rather than seconds. So if you're like me and you're a visual person, you still have no idea what we do. So before I get into Clojure, let's just give you a tiny bit quick video, which I don't think you'll be able to see it there, but you can look it up after. What does the product look like? It's just very simple, one of our search functionalities, so you can have an idea what NomNom is doing. Cool. Let's get to the interesting bit. When the company was founded 2 years ago, they done the obvious thing as a startup. They wrote Ruby on Rails application and they backed it up by Postgres. Already at the time, they were smart enough that there was some of the heavy integration processing was done in separate Ruby integration workers. And because Postgres, of course, would be very bad for full-text searching, there was some Elasticsearch. And it worked fine. It worked fine that the prototype worked and the company went through Techstars through London. But the model you're seeing in there, it very quickly reached a point where it was not scalable. And it was not scalable for 2 reasons. It was very hard to add new features which were required. And it was also very hard to start handling bigger traffic. So what were some of the reasons why it needed to change? So one of the first big one was missing NLP libraries. So at the time, there was a big push to do more machine learning and natural language processing. And Ruby, comparing to languages like Java and Python, don't really have such a great support for those. The next one was a need for better data storage. The data model didn't change much, but it shows that if you have 1 million of documents and you quite frequently updating and creating JSON blobs in Postgres, it's not going to scale well. there was other performance issues, and the other performance issues were coming from Ruby being mainly single-threaded. I mean, you can do multi-threading there, but it's quite complicated, and running some of the integrations in a reasonable performance, it required big machines, and that was a big cost for the startup. And the last reason is always questionable. It's how long should you run your prototype app? So you have an idea, you build your app, and you might go through one of those programs and your idea completely changed because you realize people want something else, you realize your assumptions were wrong. So sometimes it's easier to build things from start rather than trying to fix them. Now, a spoiler alert, they decided to go to Clojure. And at the time, I wasn't part of the company. I was hired to help them with the move to the Clojure. And I think it was a very brave decision to do this Clojure turn, because there was a CTO and other backend developer, and both of them only like functional programming, and both of them only had pet projects in Clojure. But they felt so strongly that Clojure was the right tool for the job that they were willing to take the risk to move on. So why Clojure? The first reason is because Clojure runs on JVM, and JVM is battle tested, it's very well performant, and it's not as hard to get your things running and deploy running on JVM. The next one is the Java interop. So as I was saying, one of the reasons why they couldn't build the functionality fast enough was because there wasn't such a support for the libraries. And if you are using Clojure, you can use Java, and you can use it so easily. So all the things you can access in Java, you access in Clojure. And a concurrent processing. So I think that's one of the reasons lots of people move to Clojure, because they heard how good it is in concurrent processing and how easy it is to do multi-threading and all that stuff. And it is true, because it's all built into Clojure core, so it's super simple. And it is super fast. The next reason why you maybe can say what's a good reason to move to Clojure is the data representation. Because your data are immutable, it means anytime, I think most of the companies, it doesn't matter what kind of data you're working with. We work with customer feedback, but it is a map of data. When your data are immutable, it's much easier to reason about your program, and it's much easier to debug your program because you're just passing it through some functions. And the last reasons why they decided to go for Clojure is, well, maybe not the last point, but most of the points above, they could have just worked with Java, but they didn't want to use Java. They were like, we want to write something which we will enjoy working on, so let's move to Clojure. And they did. So the first step, I forgot, I really like this quote. It was from our CTO. It was in some Intercom developer blog post where he said that we moved to Clojure because of JVM, and we stayed for everything else. And I myself have experience in Clojure probably for over 4 years, but it was lovely to see them as they were discovering more and more Clojure, how they didn't really have a bad experience. They were more like amazed, this is a great tool, and we want to use it from now forever. So as they were migrating, the first part of migration was really easy because they just added a new service. So it was not really a migration. They just added some natural languages processing services, and it was dummy enough. It was just communicating with the workers through HTTP, and it was backed up by some Java libraries. And it proved to be working. Great, let's move to Clojure. So what was the next problem I was saying that needed to be tackled? The data storage. Now, that proven to be a tiny bit more difficult because it wasn't just replacing the code talking to database, but it was replacing the database itself. At the moment, we are using RethinkDB. I think I could give a whole other talk why you should and shouldn't use RethinkDB. We're pretty happy with it. For the traffic we're handling, we don't have any performance issues. There are some funny things like that you can write a query which will shut down your whole database. We did experience it in production, so we know not to do it anymore. But it works well. And one of the reasons why we chose it is because the query language in RethinkDB is looks very functional. So it fits very well with the Clojure. And it, of course, gives us the issues with the updates and everything, it worked well for us. So how the migration went. The workers which were downloading the data from the third-party APIs were sending some internal format for our core data processing Clojure service. The core service was communicated with some other libraries, and it was then storing the data and indexing them. What did it mean? We could have dumped the Rails services a bit more, because they were only, at that moment, they were still asking, all the querying was still done in the Rails, but they were no longer accessing the data model. And I think this is a great example where it's much easier if you're going to migrate your application step by step, rather than that you're going to say, well, I'll turn off the Ruby and I turn on Clojure and Clojure script. Not many companies can afford it, but you can do it adding a new functionality and moving the services step by step. That worked really well for us. With that said, this is and this was the time where I joined the company, and the next big task was we now need to sort out the integration workers so we can implement more integrations, so we can support what our customers want. And we start seeing that there was issues across Clojure services, which were quite common. So the first issue, the first issue we had was a correct JVM setup, and that was something what we actually managed to get by, and I did say it's easy to set it up, but you have to be quite careful when you're not used to working with it. I think there was silly things like, setting a wrong number of threads because we use a wrong keyword, or mixing high CPU with loads of I/O operation. It means that you completely over-provision your machines and your Amazon bill goes out of the roof. Other funny thing was that regexes in Java and Ruby are a bit different. That means we had a bug which caused an extreme memory leak once it was deployed. But those were the things which it's a learning curve, and I think it happens anytime you change it to something new, there will be some bad surprises. But the two things I want to talk a bit more, and I want to talk why the component library really helped us, is about application structure. And let's say if you're coming from somewhere like Rails. In Rails, you really have somebody hold you by your hand. They tell you, okay, this is where you put your database code. This is where you put your handlers. And then you go to Clojure, and it's all pure function, and it's all pretty. But at the moment, there is not that many frameworks, and there is not that many guidance as actually what's the correct application structure. And we'll talk about it a bit more in detail. And the other one was how you manage a state in the application. So again, Clojure, functional programming, what you're speaking about, this is not to do anything in Clojure, but as soon as you're running your code in production, you will need a state, configuration and stuff like that. And again, we'll speak about it in a bit more detail, but I think Clojure is still lacking their guidance how to do it. Let's start with how to structure your Clojure application. What does that mean? So they are, in my opinion, there's two things when you're structuring code base. There is how you're going to structure your code, and there is also how you're going to structure your business logic. And in one of the talks, when I was preparing for this, there was a talk from Stuart Holloway, and he said, if your application is more than 2 weeks old, your biggest problem is the complexity of your code. So as soon as you get past the pet project phase, having a complex code is the biggest problem, and you just want a simple code everybody can read. So how can you organize your Clojure code? I think everybody knows about namespaces. So namespaces, that's pretty simple. Namespaces there, it will just going to be the set of your related data and functions. And even inside the namespace, you might want to, split it by some common blocks. As your code base is growing, you will have more services, and you will extract the shared code into a library, so that kind of helps. But this is still really only speaking about how you're structuring your code. It doesn't really says how do you structure your business logic. It doesn't really help. Well, okay, you have maybe some databases, namespaces starts in a path where there's a DB in the namespace, but there is no structure to it. And that's where I think protocols really help. So I think probably all of you heard about protocols, because they're in Clojure, I think, since 1.2. And protocol is in Clojure the basic mechanism for abstraction. Show an example in a sec. So what does it mean? You know, when you have a protocol, really, when you define a protocol, you only define the specification, and you don't worry about the implementation. And what does it mean? You know, it produces you functions which you can then dispatch on the data types. So you have this polymorphism, which is great. And you can also, like, if you're just looking for polymorphism, you might as well be using multi-methods, because there you can dispatch on class type and on a function. But there's definitely the polymorphism as well. But I think for us it was more important that the protocols were giving us these boundaries between the subsystems we have not seen before. So let's say, as an example, so let's say I have an interface which is I integration DB, and I have two methods there, and they're just called get integration for ID and get integrations for sources. And what I expect, that is going to load some data from database. And I have it specified in there. And I don't really, when I'm defining the protocol, I don't worry how is it going to be done. I might then use def record to implement this protocol. Now, you can use various. I mean, you can use, most commonly you would use def record or you would use def type to implement protocols. I prefer def records because beside being able to implement the protocol functions, it's always, def record is like a hash map. So on top of it, you have all the hash map. Once you create a def record, you have all the functions hash map has, and you don't get that with def type. So our record then have some implementation of the function, and it's very simple. It's just said, okay, I initiate the def record with some database connection, so that anytime I call the protocol method, I know it's just going to use the database connection and search with those parameters and return me the value which are in database. And as a good practice, usually you would also have a constructor function which just initiates the def record. So that would be kind of our interface. And the reason why is that handy is that because then if you're in your Clojure application, anywhere in your code, pretty much, let's say you have some like a web layer, and then you have a business layer, and then you have a database layer. So when you're in your business layer, anywhere in there you can really decide, okay, so I define my database in here, which will define records with some database connection, and I can just anywhere in code I can use this. And I on purpose just put it there kind of randomly on a blank screen, not in some function, because though protocol did solve for us this boundaries between subsystems, it didn't solve for us the other problem, and it was the problem with the state. So if we go back, we can see that in here we were, as a part of the constructor, we were creating a database connection. It means we were creating some state. There was an open connection to database. And then this code could have been called anywhere in namespaces. It could have been really deep down. So you might came to a code base, and we're a small company, we grow fast, we really quickly change the code. So you might go to a service which somebody else written, and you have no idea where stateful things are. So you just debug through the code. And when there's issues, it's really hard to see what's going on, because you don't have that purity anymore. So that's the next thing I want to talk about before we get to that, how we solve the components, and that's how do you handle state in Clojure. State is a hard thing. Everybody thinks about it something else. For me, state is like a value at a time. And also people always talk about two different things. So I just try to define it in my definition, like in the biggest two problems is that you have something what's like a mutable state and something what's like a shared state. And to be fair, the mutable state is something what's handled in Clojure extremely well. There is an article from Rich Hickey about state. It took me about 10 times and 2 years till I understood what he meant by it. But eventually you get it into your head when you work at it enough. And he says there that in past, state was always looked as a content of the memory block. But now we should rather look at the state as the value associated with an identity at a given time. And what does it mean? That state doesn't change. Identity can just get a new state. And why is this relevant? So let's say if you have in your application, you might have a memory cache, or you might be doing this concurrent processing. You need to be careful how you accessing things, because you want to keep things in sync and stuff like that. So you need to have some handling of this state. Well, the good thing is you don't have to worry about this. It's all solved. I mean, like there's atoms, there's refs, there's agents. So depending on your problem, like 99% of cases, we got a solution using those. The problem we had was looking at shared state. So what's the difference? Let's say a shared state is something what's accessible from like many namespaces. And now I don't mean some like terrible global mutable state where you have in Java and you have some object everything can access and it can change its values. I more mean like things, maybe you will have the open connections to database or some channels to RabbitMQ or some global accessible configuration. And those things, they're not really mutable because you start your application, you initiate them, and once you've done it, it doesn't change. So mutability not required during runtime. It is kind of required once you initiate your application, but later on, you don't have to worry about it anymore. Once you initiate it, you don't have to worry about it. And we had a real problem how to deal with it in some sensible manner. So let me give you a tour how we arrived on a component. So application configuration. When they first wrote any Clojure, anytime they needed to know, for example, what port am I supposed to connect? They, because we're using Ansible, we have our environment, we have our configuration and environment variables. So anytime they needed to know what port to connect, they just loaded the environment variable through Clojure code. Not a great way because you have no idea what's the state of that application. Whatever is in the environment, but it's not visible from the code. So then, I think there was actually Stuart here, I had a talk maybe 3 years ago where he was saying, well, you should keep all your state in one place, so it is visible. It's still stateful, but you should keep it in one place. So yes, we put our configuration in single atom. How did it work? It was very simple. We have an atom called config, and we have a function called init. So when we have our main method to start the application, we just set the config to some map, which is some mixture of defaults and the environment keys. And then we can always access the config, or we have like a function to access it. Great, it worked reasonably well. It gave us a bit more visibility what the stateful configuration is. So we said, because we have more and more Clojure services, let's make a library from it. So we did. And then we said, okay, let's change all the current services to use it. Well, it showed that we had a code like this. Like this. We also had a code like that. And that looks reasonable, doesn't it? Okay, so I defined some channel. And that channel is defined, the first time I define it, I open a channel, giving my configuration atom, and then anytime I need to publish, I'm using the channel. And the reason why we do it, because you don't want to open a channel every single time you want to publish a message. It really is kind of heavy on RabbitMQ or really any queuing system you're using. What's the problem with it? The problem with it is that what if this namespace is compiled before this? So that means you define this was run when the config was maybe not initiated and the config was empty map. In good occasions, your application is going to blow up when you're starting it up. In a bad occasion, it's going to start up fine because it doesn't matter that you have a nil in here. And then eventually, maybe a few hours later, the function actually gets evaluated and you're like, why is this not working? Well, it's okay, we're developers. We like to do workarounds. What do? Where's my thing? You put a delay and then you make sure that you deref it, and okay, when I'm calling this function, I know the config was initiated. It works fine. But yeah, it was exactly like having those few hacks. We were we need to solve this somehow better. So we went through the few steps. We looked in Mount, and how many of you heard about Mount library? Yeah, so good few as well. So Mount is really one of the I think he said it himself in his GitHub README that it's an alternative to component. And it's an alternative way how to manage your state, and your state is defined within the namespaces. I think it works well, but at the time, mount was only solving the configuration issue, whereas component gave us both. Because various components gave us both the application structure and the configuration. So we said, great, let's move things to component. How did we done it? So currently, this is kind of how our application infra looks like. I mean, similar as the before, the picture before, I should have said. I mean, it's of course very much dumbed down. Like we use RabbitMQ, we use Redis, we use S3, but that's not really relevant for how the data are flowing. So as you can see, we have still our core data processing service. There is more inputs to it. So besides integration workers with many integrations, we also have services for document upload or for public API. And we dump down the Rails a lot. So it really kind of now is handling the things around user management and so on. Now, we kept Postgres for that because, I mean, relationship databases are good for some things, and things like your user or subscription management. Same goes with Rails. I mean, there's no point rewriting a code which is Rails done for. Like, there's no point rewriting your account management into a Clojure because you're not going to get much better. So that looks good. And if we look, let's say, more in the details in one of the components, one of the Clojure applications. So let's say our integration workers. They actually do a lot of things. So there is loads of the actual workers for each of the integrations, but also they also need to talk to Postgres, they need to talk to Redis, they need to talk to the third-party APIs, there is a scheduler, there's maybe some web servers for some real-time processing. Some people ask, why did we not move it to like a smaller microservices? Now, in my experience, when the team is too small, microservices are not a great solution because it adds an awful lot of overhead. So for us, but you know, everybody's have a different experience, but for us, like keeping it in kind of more service-oriented architecture worked better. So this was all happening within one Clojure application. And this is how our startup looked before, start function looked before. Okay, so great. You initiate your configuration, you maybe set up some error notification and some stats, and then you start your workers and you start your scheduler. And you have actually absolutely no idea what have happened there. Because you have no idea you have to click through all those namespaces to actually get a picture what your system looks like. So if you didn't write that code, you go in here, you spend half an hour just clicking through namespaces to get a picture of what's actually happening. So there we go. How is this done in Stuart Sierra component? So, because there was already so many talks on a component, I'll just take it very briefly, what component is and how does it work. And if you have one more question about it and if you want to more explain how could you use it, you can just talk to me after. So component is a framework and it was built on purpose for the same frustration of not knowing how to manage a state. So it's helping you to manage the lifecycle and dependencies of components which has a runtime state. What can it be? So what could be a component? So exactly as I was showing, the component could be things like a database access, it could be like external API services, it could be your web server. And the component is built around that you have some way how to start a component, how to stop a component, where you handle the state. But also the big future is that you can create a system of components where you can specify how the things are depending on each other. And it makes sure when you're starting a system, it makes sure that the system is going to get started up in a correct order. Which, by the way, happened to us as well. We were, for example, starting the scheduler before the consumers, which meant that the scheduler was publishing message to a queue which didn't exist, which didn't mind. Great. So this is not going to happen to you when you're using the system. It was quite easy for us to migrate some of the smaller code bases because if you're already using a protocols, component is really built around one protocol. And what's component built around? It's built around this component lifecycle, which is a protocol, and there's two methods. There is a start and stop. So you can have your protocol, let's say integration DB, which is still implementing the functions the same as before. But on top of it, it says like, okay, when I'm starting this, I want to take some configuration, and I want to create a database connection, And when I'm stopping it, I have my component where the connection was added. So now I can get the connection and I can close it and I can remove it. So I know other things using it, the connection is no longer available there. As a good practice, you have a constructor wrap around it, and as a good practice, it is that you don't do any kind of stateful operations like creating database connections in the constructor. And this would make it really easy, because then what does it mean is that when you have your system defined, and this is kind of a dumbed down version, I hope you can see it, it's not too small. This is kind of a dumbed down version of how our system looked like. You can see that all the things which are being started, and you can see the direct dependencies. So you can, for example, see that maybe a scheduler in here depends. Scheduler creates some component, which is a start and stop function, which obviously on a start, it starts ticking the scheduler. But you can see it depends on the exception tracker, integration DB, and publish channel. So that gives you great visibility. Not only that you see exactly what's running in your code, but if you have a problem, like, let's say, for example, if you have a problem with Integrom integration, you say, okay, so I am only concerned about this part of the code base. I don't care about this part because that has nothing to do with it. So it gives a great, if you have a small team and the people are working in different places and if they have to jump in, it gives them a much quicker way how to walk through the code. And so let's say this is our defined system map, and then what does it mean is that when you have your init function, all you do is that, okay, you load your configuration. That can, for example, load it just from the file or from the environment variables. You define your system, giving it a configuration. So see in here, I defined a state, but I'm just passing it into the production system, and then I start it. And what happens is that the configuration gets passed. Whatever it needs to be, whenever the configuration needs to be held in, it gets added into the def records. So it's just the def record which holds the state. There's no longer a random def somewhere nested deep in a namespace which defining stateful things. And it starts the components in the right order. So it knows it can't start, let's say, web server until it has all the other things started, because they need to be available for it. When we get to the part what's not so bad about a component, I explain this try-catch statement. But how it solved our problem. So it really helped us to enforce the structure in our code. And what we were missing, especially because we're not, a very, very inexperienced Clojure team. It was good to kind of have a way how to structure the code so everybody follows the same pattern. State is now defined in a single place, so there is no some bad surprises like, oh, actually I opened this DB connection and this DB connection opened when this function was called, which might have been at this time in past. And you have this great visibility of the system. Now, when we were moving the components, we kind of knew about those things. What we didn't know is how it's going to help us in other ways. And it really helped us in testing. So you'll be thinking, it's quite obvious one, is that you could write mock components, and I think it was kind of mentioned here in the previous talk, that you could replace your third-party clients with a mock third-party client. And that's great. It's also for it also, of course, helps with the unit testing, because you no longer have to use a with redefs, but sometimes with redef is still a bit simpler. But it really helps when you have more like an integration testing. And now I'm not talking about end-to-end testing, but maybe you have a piece of code which has some business logic. And with the components, I'll present it on an example. With the components, you can much more model better a real-world system. And of course, if the testing, we're trying to use it for end-to-end testing. We're not quite there yet, but it gives you a really nice feature, because you can take exactly your production system. You can specify different configurations, so you're pointing to your test database. And all you need to change is the third-party clients to be mock components, and you can start running your end-to-end tests. So let's talk about an example how you can use the components in your testing. So let's say somewhere in our scheduler we have a function which is called schedule integration source, and it gets two arguments. It gets a source, which can be, for example, intercom, some string, and it gets a system. Now, really, I should have called it here more like a subsystem, because it gets whatever was the injected dependencies. So maybe this is a function which gets evaluated on every tick of the scheduler. And the system in here is when we had the defined systems, we had that the scheduler was depending on exception tracker, on integration DB, on a published channel. So that's the components I have available in here. And the components are available, so that means I can just call, what I want to in here. Well, I want to load all the integrations from a database for a given source, and I get all their IDs, and I want to publish them for processing to the queue, and I want to use the published channel because I don't want to be opening a new channel to RabbitMQ again. Great, how did you test it before? Something like this. You had a redef, you put in their functions, you said, am I getting the right argument? Great, I want to return this. Am I getting the right argument in here? Great, works. What's the problem with this is that it happened to me awful lot of time that you are going to make a mistake in your unit test, which is going to cover up the mistake in the code, because this is not very native to read. You're testing the values, but you're not really seeing the business logic. So you can use your mock components. So the mock components can exactly help you just in a unit testing by very simple, I rewrite my mock integration DB is going to return to me, depending on a source, some values. Or you can go a bit more tricky. So I can, for example, have a mock RabbitMQ channel, which actually have a start and stop. Pardon. And on a start, it's going to add to the def record, we're going to add to the hash map a key RabbitMQ with an empty atom. And then every single time we call a publish on that component, we know we just want to update that atom. And we want to, in the atom, we want to update the key with the name of the queue, and we want to add the data we're publishing. How does that look like then in a test? So you have a test where you start your system at the start, and then you check, okay, I started the system. Is there anything in a RabbitMQ? No, it's not, and it shouldn't be. Like, I started a new system. Well, let's schedule some sources. And then I said, okay, now my RabbitMQ in the queues should no longer be empty. So I can deref the atom stored in there, and I can see, okay, well, I have a queue intercom worker with those IDs, and I have a queue des worker with those IDs. Now, of course, this is quite simple example where you would get away with the redefs, but once you get a bit more complex codes, it really helps when you have the integration test more presenting your business case than just the code. Oh yeah, sorry. There we go. One more thing about here, it's extremely fast to start and stop the system. So you can do it as many times as you want. You can, of course, you could have a namespace and you could put it in a fixture to restart the system between each of the tests, because it's very fast, it doesn't cost you anything. Which is one of the reasons why it's so good for REPL. REPL is one of the things I really, really love about Clojure. The development of the REPL is so fast, because you're just testing it all the time, what you're doing. And the good thing is that you can define a development system which will be the same as a production system of those components, and you just replace the few pieces, which you knew you can't use the real ones. You can also have multiple systems under single JVM, so a single REPL, you can run multiple systems, so you can be testing two things at the same time without restarting anything. And that's really the thing, you don't no longer need to restart REPL. I don't know if any of you experience the pain when you have to restart REPL. If you have a bigger code base with dependencies, it might take 10 seconds and you're waiting. And of course, there's various workarounds how people use it. But I just like that it works so well with REPL. With components. So I was thinking I'm going to give you here live coding session, but you never have a time for it, so we can do it after if you're interested. So this is how we usually do it. So in each of the projects, see in here, I have a nice Dutch days, we define a namespace user. Now, we call it a user, it was because when I first found that example 2 years ago, somebody called it user and it just stick. And in there, we define our development system, which will be something like a production system, but you might want to add some fake or even remove some parts. But usually it's easier to add fakes because you have the dependency injection. So if they would be missing, the system would be complaining when starting up. And you have a free, very important function. You have a start, stop, and reset. So you start your component and everything's running fine, you're testing it, and then you start getting a terrible, terrible amount of exceptions. You quickly stop it because you don't like your REPL going mad. You fix your code and you call reset. And what does the reset will do? It will go through all of the thing, because you're using the Clojure till namespace REPL, it will just go through all namespaces with changes, and it restarts the whole system, and that means it will reload the configuration. So even if you change your environment variables to point to a different database, it will change it. And it's all done with one click without restarting the repo. So the development is so much faster. Okay, and the last bit is how it helps us in production. So spoiler for a start, avoid accessing production system. So I don't know if you use nREPL to access your production system. It's great, you can poke around, you see what's happening. Yeah, we managed to call the altravar on a production system in past, and suddenly things start looking odd in the app because it was a future branch deployed into a production with one click. So yeah, make sure that can happen because people don't want to do it, but it will happen by an accident. But really what it helps it helps you to, because you have such a good visualization of the system and you know the where the subsystem boundaries are, it's extremely easy to debug because you can just take the part of the subsystem which is broken and you can run it in your dev mode, changing a few of the components. So the debugging is the big thing. But we don't do the poking into the production system anymore. But what we do is that because we're such a young company, we often get things wrong and we say, okay, we need to re-import all the intercom data for this customer because they want different mapping. What we can now do is that we can just add ad hoc components. And what does that mean is that you had because you know all those components are working exactly as they're supposed to be, you don't want to put the whole process of migration on your current system, on your current queue. Well, you can very quickly just add a new component, which is kind of using all the other things which were tested, and it's just doing tiny bit of different work. And it means it's super fast to use it because those things are battle tested and they're tested how they work together. So you can very quickly add something new, deploy it there, have it there for a while, and then remove it again. Okay, I think I have only a few more minutes, so very quickly, the bad parts. It's all or nothing. I will be honest, our core data processing service is still not using components because it was too painful to rewrite. But if your services are not that big, it's definitely worth kind of, and rewrites are not bad if you have time for it, you get a better code. But it's definitely hard to rewrite existing code base because the system or subsystem have to be passed through all the functions. We had some funny failures during system startup, which were kind of quietened down and nothing happened. And that's why we add there the try-catch statement and the logging the exception, because we may be thinking our system started up and everything is fine, but there was a little error which never got propagated everywhere. Don't try to use wrappers. So imagine you have a few components and each of the services always use the same set of the components. And you say, okay, I'm going to put a library which is using those components together. And that's not a great idea because you're referencing to the library, you're losing this great visibility as we had in the system map. Integration with other libraries, but that may be more we can use the other libraries which are using components. And what I personally fought a lot with was the OO approach. So when I was the one which came with like, let's use components, and the first 2 months I was kept from like, this doesn't feel like Clojure, I really don't like it. But the value it gave us, like, yes, it's not a pure functions, but it does, it helps you to build the application fast. So that's the end of the journey. At the moment, we have about 90% of data processing in a Clojure, and we're very happy with it. So I guess just my takeaway is that, yes, you can do the migration in reasonable safe way. Yes, components maybe are not the most pure Clojure thing, but they help. And the other thing is that, like, don't migrate everything to Clojure just because Clojure is the buzzword. Use the tool which kind of works for your business, because I think sometimes it's more like we programmers forget that building the product is actually, what you want to do. It's not the nicest code, it's having the best product. So that's me. And questions?
Thank you. We have time for maybe 2 questions. Anyone? No? Okay, so I guess everybody knows how to... Oh, sorry. Sure.
Hi, great talk. Ruby on Rails also helps you to, with the different structure, it also tells you this should go there, this should go there. It helps you set the boundaries also a little bit. Does components also help you set the boundaries, or do you have to invent that yourself?
Yeah, you have to do it yourself. So it's kind of the using the protocols, you know, because components works on the def records which are using the protocols. The component doesn't tell you put this where. It just gives you the tool to create the boundaries, but you have to create the boundaries yourself.
Okay. Any more questions? No? Okay. That's it from, well, sorry. Not that's it from, I just wanted to give you our special speaker gift. If you have any questions, of course, you can talk to Marketa. And thanks a lot for the talk. And thanks for flying all the way from Prague.
No, it's lovely here. I really like Amsterdam. Yeah. I'm enjoying it here so far.
So we're going to open the doors a bit, and then again, we'll be back here in at 2:15. Again, there is coffee and some water and drinks, etc. So take a break, and then we'll be back at 2:15.